All right, identify quadratic patterns. So the first question we want to factor the following expression. Which pattern can we use to factor the expression? U and V are either constant integers or single variable expressions. So what they're trying to do here is just be able to understand that there are patterns in factoring, and they can be spotted kind of easily, but you have to be familiar with them. So what I have over here is the question, but we're actually going to move on to the answers real fast and talk about those. So the black one is our A option, okay? So I have U plus V squared or U minus V squared in black right here. So let's talk about those. I'm actually going to erase option B for now. So I have what U plus V squared is actually equal to, and I have what U minus V squared is equal to. Let's do box method for the first one. Okay, so I'll do U plus V, U plus V. All right, U times U is U squared. I'm going to do, then U plus V is UV, and then U times V is UV. If I said U plus, it should have been U times V. And then V times V is V squared. And I'll do this one in, I guess, black. So V squared. So these are positive, and they're the same thing. So these are the only like terms down here. So what we get out of here is we get U squared. And then we get plus 1, 2 U V's. And finally, we have 1 V squared. So this would be our answer for the top one. Okay, now let's go do the second one, the negative one. And there's a reason why these are grouped together. So that's negative and that's negative. Well, what's the thing that changes? The only thing that changes are these two red ones. They now become U times negative V is negative, and U times negative V is negative. Negative times negative is still a positive V squared, and this is untouched. So the only thing that's changed is this middle term goes from positive to negative now. So if you have a U plus V squared or a U minus V squared, it's going to be the U squared and the V squared, and the middle is just dependent on the sign. You're going to have two UVs, U times V, whatever that is. And we can go look at the question that we have for this problem, and we have our, let's say this is our U, x minus 1 would be our U, and then square root of 4 is 2, right? So that would be our V, or here and here. So we have our x minus 1, but what we don't have is we don't have a U out in front of our, sorry, not a U, our V, right? Because this would be square root of 4 is 2. So we should have a 2 times x minus 1. And then we also need an additional 2 out here. So we should have a 4 sitting in front of this x minus 1 if we have one of the patterns in our A option. Since it's positive, it would be in the positive option. This could also be negative. It would just be the negative option. It would be down here. This is probably a little confusing right now. So basically the answer right now is not A, we just discovered. Because we should have a square root of 4 sitting in front of our x minus 1. And in addition to that, we should have it doubled up. Because you have two UVs. We only have our U sitting here. We don't have a V, and we don't have the 2 sitting in front. So let me erase this board. Now let's talk about number B, letter B. U plus V times U minus V. All right. So when we do this, we're going to box method it. All right, U and V, that's my positive 1. Actually, I'll make it my negative 1. And then my positive 1 is down here. I don't know why I changed it, but I did. So U squared, U times negative V is negative UV. Then we got UV positive, and then negative V squared. So this is the difference of two squares. I should have written it in different colors, sorry. So these ones, instead of adding to each other and getting a 2 out in front, they cancel each other out. So this is, remember how we had differences of squares? So if you have U squared plus V, sorry, not plus, difference is subtraction. and that's subtraction right here, we know we can factor this into u plus v and u minus v. So we can look at question B, and we don't have two terms there. We have three terms. That's a trinomial, essentially. So it's not B. So the answer for this question would be C. All right. So now let's just look at the patterns, and we're going to talk through them now. Okay, so we have a subtraction problem here, and we have one term, which is x minus 2, and then y plus 3. What could be the square root of both of these things? So right now, if you're looking at this, it's got to be either this one or, well, actually, I guess it doesn't have to be. We don't really know yet. So, okay, oops, I didn't write it down yet. So we have x minus 2 to the 4th, y plus 3 to the 4th. Okay, so what we want to do is look at, there's a difference here, subtraction. So do we have something that we can take, like a square root of both of these things? Well, we could take x minus 2 squared, and that would be the square root of that. And we can do the same thing over here, square root this, and we get y plus 3 squared. So our u is equal to all of this, and our v is equal to all of that. So we could have u squared minus v squared. And if we plug in this for u, we end up with that. Okay, so this is going to be C, because we have cubed up here. So we can't square root that. That doesn't work. We have 5 right here. So if this is a 4 or a 2, it would work. But because it's a 3, it does not work. The back side is good, but the front side is not. And finally, okay, this looks like it's going to be A. So if you remember our first question, this is our u right here, and we can see our u again. Our v is the square root of 25, which is going to be 5. So we don't have a 5 here, we have a 10, but that's because we have 2 times 5. Remember that 2, we have to have 2 of these in here. So we get 10 in there. So it's going to be A, and it's actually going to be the negative option because we have a negative 10 in here. But we don't actually have to select that. That's where it comes from. It's the u minus v squared one. Okay, and we're done. This assignment is difficult. If you don't understand this assignment, feel free to move on. And